everybody, we're going to look at your morning work for the week of April 13th through the 17th. So Monday number one, sorry, my paper is over here. Monday number one says, what is the quotient of 9 and 836 thousandths divided by 2? Quotient, of course, means the answer when I divide. So 9 and 836 thousandths is my dividend, not because it's bigger necessarily. You can have a smaller number as your dividend, but because it's listed first in the expression. I'm dividing that by 2. Okay, so remember when I divide with decimals, I just need a happy whole number divisor. So if I already have a whole number, I don't need to move this decimal left or right. I don't need to multiply or divide by a power of 10. My decimal can just go straight up into the quotient. Plus, if I estimate, if I rounded this number to the nearest whole number, which would be 10, 10 divided by 2 is 5. So I know that my answer should be close to 5, and that will help me make sure that the decimal is in the right place. So 2 will go into 9 4 times. 2 groups of 4, 2 times 4 is 8. I subtract and I get 1, and then I bring down this 8. 2 will go into 18 9 times. 2 times 9 is 18. Bring down my 3. 2 goes into 3 1 time. 2 times 1 is 2. I subtract and get 1. Bring down the 6. 2 goes into 16 8 times, and 2 times 8 is 16. Okay, so my answer is 4 and 918 thousandths. And that's really close to 5. So if you accidentally had your decimal in the wrong place, and that is easy to do when you divide, you could see that it is close to my estimation. So if I had the decimal here, or even here or here, for example, I would know that that's pretty far off from my estimation. Okay? Number 2 for Monday says, Jill has a bag of Cheez-Its. I love Cheez-Its. Jill has a bag of Cheez-Its. If each bag contains 32.5 or 32 5/10 Cheez-Its crackers, how many Cheez-It crackers does Jill have in all? So we could add, but it would be very awkward to try to add a decimal amount, a decimal number of times. So the easiest would be to multiply. So she has a bunch of bags of Cheez-Its, and each bag has 32.5 crackers, because sometimes they break, or there's a problem maybe at the factory and the Cheez-It got split into 2 different bags. So she has 32.5 Cheez-Its per bag, and she has 5 8/10 bags of Cheez-Its. We want to know how many she has in all. Again, I encourage you, before you multiply with decimals, to always estimate by rounding to a whole number to see what your answer should be close to, and that's going to help you know if your decimal is in the right place. So I can round 32.5 to 33, and then 5 8/10 to 6, and I can multiply that. Another way to make it even a little bit simpler to multiply in your head, I could even just round this down to 30, and then I could round this to 6. And I could use Veronica and powers of 10. I know that 6 times 3 is 18, plus my 0 on the end. Only because that's whole numbers, I can add that 0. So my answer should be close to 180. Okay, so then I'm going to multiply by ignoring the decimals first. 8 times 5 is 40. 8 times 2 is 16, plus 4 is 20. 8 times 3 is 24, plus 2 is 26. Okay, before I move to the left, I'm really multiplying by 10 or getting 10 times larger as far as place value. That's why I need to add my placeholder. 5 times 5 is 25. 5 times 2 is 10, plus 2 is 12. 5 times 3 is 15, plus 1 is 16. And then I'm going to add those partial products. So I have 0, 5, 8, 8, and 1. Just based off of my estimation, I can see where the decimal should go, but remember that you can also count the number of places after the decimal in each factor. So there's 1 place after my decimal here, one place after the decimal here or 2 places after the decimal, which means it's going to go right here. And that is really close to my estimate as well. So 188 and 50 hundredths, or you could say and 5 tenths, or you could say and 1/2. That's how many Cheez-Its she has altogether. Okay. Tuesday number 1 says, what is 459 thousandths rounded to the nearest tenth? So my tenths place is here. This is my hundredths and my thousandths. Tenths place, I'm going to look next door. 5 or more raise the score. So my 4 is going to raise up to a 5. And this number would round to 5 tenths as the nearest tenths place. Oh, this page is dirty from, you probably can't see that. There's lots of little marks on there, but it's okay. All right, Tuesday number 2 says find the value of 8 and 63 hundredths divided by 1,000. So for this problem, I can't really use Veronica because I don't have a whole number that I am dividing with powers of 10. I have a decimal number, so I'm going to use Mr. Dull. And remember that for Mr. Dull, if I am dividing, the decimal is going to move to the left. So I'm going to rewrite my number with some zeros to the left, okay? And I'm moving the decimal to the left by 3 powers of 10, or 3 places to the left. So I can just go 1, 2, 3. Here's my decimal. If I moved it, that means this one is no longer there. And then I can take away all those little loops and rewrite my number. Goodness, it's a little sloppy, but hopefully you can see that. 0.00863 would be the answer after you divide. So this is my answer for Tuesday number 2. Wednesday, okay, Wednesday number 1 is 9 divided by 1/5. So first of all, I have a whole number and I have a fraction. And so the way I can turn this whole number into a fraction is just to add a 1 as my denominator. I did not change the amount any. Remember that fraction bar equals division. So 9 divided by 1 still equals 9, or the whole number that I started with. I'm not changing the value, I'm just changing how it looks. And then when I divide with fractions, remember I'm going to use keep, change, flip. We listened to the vocabulary about it. It gets stuck in your head a little bit, or it does for me. But I'm going to use keep, change, flip. So this is going to be 9 over 1. This is going to change to multiplication. And then this is going to just flip. So my 5 is now the numerator, 1 is the denominator. And then I can just multiply straight across. So 9 times 5 is 45. 1 times 1 is 1. So I have 45 over 1, but I really don't need that denominator because 45 divided by 1 also equals 45. So my final answer is just plain old 45, the whole number. Okay, Wednesday number 2. Wednesday number 2 says, Gerald spent 60 cents on 5 stickers. Each sticker cost the same amount. How much did each sticker cost? Be really careful on this one. I've had classes in the past, and this may have been a problem for you as well, but they've tried to do the wrong operation with this, okay? So really think about one sticker. One sticker should not cost that much money, unless it's just made of gold or something, I don't know. So he spent 60 cents on 5 stickers total, not each sticker, okay? That's when we would add or multiply if it was each sticker. He spent this amount on all 5 stickers, and that was spread out over 5 stickers, okay? So really we're taking this 60 cents and we're splitting it into fifths, or we're splitting it by 5, which means that you would divide. So just like we did on the first problem, I have 60 divided by 5. Since I have a happy whole number divisor, I'm not going to move the decimal left or right. I don't need to multiply or divide by a power of 10. I'm just going to bring that decimal straight up. Okay? 5, if I have 0, I can't pull out a group of 5, so that's going to stay at 0. 5 times 0 is 0. oops, I subtract, I get 0, and then I bring down my 6. 5 goes into 6 one time. 5 times 1 is 5. And then I get 1, and I bring down my 0. 5 goes into 10 twice. 5 times 2 is 10. So each sticker is going to cost 12 cents. That makes a lot more sense, pun intended there. That makes a lot more sense than if I multiplied 60 cents times 5 to find the price of each sticker. 12 cents is a lot more reasonable. Makes a lot more sense. I had to say it again because it was such a good joke. Okay, last day we have Thursday. Okay, Thursday number 1 says 3 2/4 times 16. Okay, so a couple of rules to remember when I'm multiplying with fractions. First of all, just like we did in the previous problem, a couple of problems back, I can make 16 a fraction by putting that over 1. My denominator is 1. It's not changing the amount like we said the last time, because 16 divided by 1 is still 16. Now, when I multiply or divide by a mixed number, I first have to turn that into an improper fraction. You could do it leaving it like a mixed number. I could say 16 times 3, and then 16 times 2/4, and then add those partial products. We did that in class, and I think we called it the loop method. I really don't know if there's a name for it or not. But you could, that is one way to solve it. 16 times 3 and 16 times 2/4. Another way to solve it to make sure you get both pieces multiplied by 16 is to turn this into an improper fraction. So that's the strategy I'm going to use right now. So I'm going to multiply first 4 times 3, which is 12, and then I'm going to add my numerator. So 12 plus 2 is 14, and then that's all going to go back over my denominator of 4. So 3 2/4 is the same thing as 14/4. I could represent that with a picture and prove that it's the same amount. I'm not changing the amount. And then I'm going to multiply times 16 over 1. Okay, so obviously my denominator, 4 times 1, is going to be 4. And then I need to multiply 14 times 16. I'm actually going to use the lattice method because I used standard algorithm already, and I really like doing all the different methods just to keep my brain malleable. And so I'm going to use the lattice method, 14 times 16. You can use whichever method you prefer. Okay, so then 1 times 1 is 0, 1. 4 times 1, 0, 4. 1 times 6 is 6, and 4 times 6 is 24. And then I'm going to add my diagonal rows. So I have 4, 6 and 4 is 10, plus 2 is 12, 1, 2, and then 0. So I have 224 over 4. Now, that is a correct answer. That is the amount that we have. But another way that we can represent that, instead of leaving it as an improper fraction, I'm going to divide to see if it will equal just a whole number or maybe a mixed number, because typically in real life we don't use improper fractions quite as much as we use mixed numbers or whole numbers, of course. Okay, so 224 is my numerator. I'm going to divide that by 4, and 4 goes into 22 5 times. 4 times 5 is 20. I subtract and get 2. Bring down my 4, and 4 goes into 24 6 times with nothing left over. So 24/4, or 24 divided by 4, equals 56 as my final answer. Okay. For the last problem of this week, it says which axis on a coordinate plane or a graph stretches horizontally. So if I think of a graph, remember it's made of 2 axes, and they actually extend in these directions as well. In 5th grade, we really just focus on the first quadrant and positive numbers. So I have a line going this way and going this way. And this way is horizontal. And then up and down is vertical. A way I remember that is that, hopefully you can see that, but a way I remember that is that, you know, I'm short, and so a lot of times people will think they're being so cool, and they're like, you're vertically challenged. And it's funny the first 100 times, and then I'm like, okay. So vertically challenged, that means I haven't grown very tall. I haven't stretched this way very much. And then the way I remember horizontal, if I look out at the horizon in the morning or the evening when the sun is rising or the sun is setting, and I see it dip down below the horizon stretches this way. So horizontal means this way. Okay, so this is your x-axis, and this is your y-axis. So for the question, it asks about the line that stretches horizontally. So that would be your x-axis. Okay, and remember when you're actually plotting points, like if you had a point on this graph, you're going to list the x coordinate first and then the y coordinate. And the way I remember that is that x comes before y in the alphabet. Okay, I hope this helped. I hope you did well on your quiz. If not, hopefully this helped you figure out what you were missing. And I hope everybody's doing well and staying healthy. And I miss y'all, and hopefully I'll see you soon. Bye.